Mark P. Otten back with you. All right, this is a one independent variable regression, sometimes called a simple regression, which I not completely sure I agree that it's always simple. So I prefer not to call it that. I prefer to call it what it is, which is a regression with one independent variable. And what we're doing here is we're using the same data that we used when we ran a correlation in R. This is mother's anxiety and birth weight as our two variables. In this case, though, there's an important theoretical difference between correlation and regression. The theoretical difference is that in regression, we are expecting one, or theorizing that one of these variables is causing effects on the other variable, or there's an IV and a DV, independent variable, dependent variable. Correlation, we just have two variables coexisting. Here we're going to do a regression. So we've hypothesized, and this is actually real life pregnancy research, mother's anxiety is the IV. If it's higher, then it might cause birth weight to go down for the baby. So that's the hypothesis. That's the setup. We've got 4 mother-baby combinations here to test this out. An extremely small sample, but that allowed us to see what the math looked like in our regression, the other regression video that I have posted. So you've got your data there, just 2 columns. Relatively straightforward looking data, actually, compared to some of our ANOVA examples. And then you've got your code here. So I'll walk you through this briefly. This first line is where it's only 3 lines of code. So the first line is packed with good stuff here. This is where the regression happens. The magic occurs. Model is where you start there. You can call that something else. I just chose to keep it at model this time. But I think if you call it, name it after your favorite family member or something, you just got to keep it consistent. So you go model there. You have to carry that down to line 2 here, and then twice down here in the bottom. Anyway, so I'm just leaving it as model. That's sort of the default. The left arrow, and then LM, which is, I believe, linear model, or that's why it's called that. Here you just got to make sure that your IV and DV are in correct order. So in R, you just got to make sure your DV is always on the left. In this case, dependent variable birth weight, tilde, there's that tilde again. It's the squiggly line. So DV, tilde, IV, in this case, IV is mother's anxiety, or mom anxiety as it's labeled. Then you go comma and data equals the name of the data set that you're using, which in this case for me was correlation regression. And then the second line is, it's like R is like ready to run it. So summary parentheses model $COEF, which I think is for coefficients. But I chose to add a third line because the third line is actually going to give you the beta value as well, in addition to the slope, which is the B, and the p-value. So you could actually run it by just running those first 2 lines. I added the third one. The third one is LM, again, parentheses, formula equals data dot frame, parentheses, scale. It looks very complicated, but you can pretty much just copy paste that whole thing as long as you make sure that whatever you call your model is in this highlighted section here. So it'd be like, if you name your model, let's say I name it LeBron James. So then you would just like put scale parentheses LeBron James $LeBron James, and then you'd make sure that LeBron James was also here and LeBron James was also here, and you'd probably be good to go. Good. Okay, let's highlight and run. And we're going to get 2 sections of output. Like I said, I have a second section that I requested there in the last line. The first section is here with your estimate. Estimate is like a A and B value. So the A is 8.36. The B for the slope is negative 0.37. And then you've got a p-value for each one as well. The p-value to interpret is here, 0.292 for the slope, suggesting that mother's anxiety is not significantly predicting birth weight for this small sample. And then we go down here to the bottom, and you've got another a couple of values that I requested. The beta down here is trying to see it on my screen. Where did it go? Okay. Yeah, the beta is, it looks weird. It's mother's anxiety negative 7.078 E negative 1. I don't know why, like the E is like times 10 to the negative 1 power. Well, they could have just put, or R could have just put negative 0.707, moving the decimal point 1 to the left, and that's exactly the same thing. So I don't know about that notation. But anyway, the beta should match SPSS negative 0.7078.